So the basic premise is on Thursday, all things being equal. On Thursday, Alex, did I not give you one? On Thursday, you guys will have a group test. On Thursday will be the free response section. On Friday will be the multiple choice. As you walk in, a deck of cards is going to be determining who is your group. Does that make sense so far? There's going to be 2 group tests, one this week, one in a week and a half, because the second half of the course takes a lot longer to go over than the first half. And then those test grades, you will not get the curve, but before you get mad at me, they are open note and a group test. And for the multiple choice, you're doing ranked choice like you do on your homework, so there's possible partial credit. So it is not being graded anywhere nearly as harsh, and you have a lot more resources than a typical unit test. Okay? So I don't feel right giving you the curve on top of, you have a group to work it through, etc. Okay? We'll go into a lot more detail about the group test on Wednesday when everybody is here. Everybody good? So today I'm going to go through just kind of the key ideas from Unit 1. Like I said, there were a couple of things that definitely on the survey that I had you guys fill out after doing the practice test last week. There were definitely a couple of things that really jumped out to me. I've added those in, specifically transformations, and then describing and comparing stuff definitely seemed to be something that you guys wanted a little bit more clarity on. So, all right. So, the reason we start with the different types of variables, it is really important from the very beginning, I don't care what type of question it is, whether it's a probability question versus a significance question versus a exploratory analysis question. When I say what is the variable of interest, every single answer that you guys do anything with should have context in it. And the context should be, like, if I read your answer and I don't have any idea what the top was about, then your answer is not being specific enough. Okay? So where this comes in is people say, oh, you need to have a control group, and then don't go into any more detail. Or, there could be bias. Okay? It's not a random sample, so it could be biased. I literally haven't given you a context, so it's not a good enough answer, okay? So that variable of interest becomes really, really important in terms of what do I need to include. And at the end of the AP exam, you're going over your free response questions, right? Like, they tell you check your test before you're done. Okay, they're not asking you to redo every question. If I were you guys, I finished my free response questions, I still have to sit there. The first thing, before I turn in my test, I'm going to go back and say, did I include context in every single answer? Because it needs to be there in almost every single answer. Okay, there's a few probability questions where it's impossible to include the context. Okay, but it needs to be there always. Everybody good? All right. Categorical variables are word answers. When you're trying to decide versus categorical or quantitative, okay? We summarize categorical variables with percents. Okay? And what can happen is I might say, 40% of Miss Meister's 5th period class is sophomores. The variable of interest there is not the 40%. Are you guys with me? The variable of interest there is the grade level of each student. So you're not looking at what the summary is, because we can still summarize categorical variables with numbers. Okay, we summarize them with numbers, but the individual responses, if I said, hey, what grade are you in? You would say, I'm a sophomore, I'm a junior, I'm a senior. Okay? I'm going to not spend a ton of time on the different graphs to represent. Dot plots are the ones that have dots on them. Histograms are kind of like those bar graphs. The vertical axis on a histogram is frequency. Okay? We call each of the bars a bin. We say how many values are in each bin. Each bin should be about the same width. Okay? Typically, like if this is if that bin goes from 1 to 3, it's really 1 to 2.9999999, etc. That the lower boundary is included, the upper boundary is not. Okay? Etc. is a stem plot. Hopefully we're comfortable with stem plots. Typically, if you draw a stem plot, you need to include a key. With a dot plot, a reminder that a dot plot, and frankly also a histogram, but if you guys are sketching a dot plot, it typically happens with a dot plot. Any statistical graph, it doesn't matter what it is. If it's of a quantitative variable, your axis needs to have scale and be actually representative so that you can see which parts are stretched out, etc. Okay? When we're doing dot plots to check, say, conditions for major skewness or outliers, folks didn't draw it against a scale, and they said there was no major skewness or outliers when maybe there was because they didn't see the stretched outness. Okay, so you can't see skewness without seeing where are those stretches. Everybody good? All right. When describing graphs, you need to be able to describe the shape. I'm not super concerned about you guys describing shape. You seem to have a good idea. The only thing that was bothersome to me after grading the FRQs, you guys, if something is approximately normal, that implies symmetric. So it cannot be skewed right and normal at the same time. Okay? Normal graphs are symmetric, bell-shaped. Okay? You can have symmetric that is bimodal. You can have symmetric that is uniform. Okay? The other thing is, if I ask you to describe the graph of a distribution, I'm not saying, if I want you to only describe the shape, what I would say is, describe the shape. If I say describe the distribution itself, I want you to describe the shape, the center, and the spread. Is everybody good? If you have unusual features such as outliers or gaps, you should identify them. And when you identify them, be specific. And when I say be specific, that includes saying where. So don't just say there is a gap between, say that there's a gap between here and here. Okay? Lastly, again, context, going back to what is the variable of interest? When you describe the center, you can use the mean or the median. When describing spread, if it's from a histogram, I would use the range, okay? Because that's the one we can see from a histogram. But other measures of spread include the standard deviation, the IQR. That's pretty much the only ones we talked a ton about. We talked a little bit about variance, but it's not very helpful in this context of Unit 1 of describing a distribution. How are we feeling so far? All right, 5-number summary. The min, Q1, the median, Q3, and the max. So, So typically, the 5 number summary is when we do with asymmetric distributions. And the mean and the standard deviation we use for symmetric. Okay? The reason we do this is the mean is very much influenced by outliers. My example to that is if we take the average age of everybody in this room right now, if we do everybody in this room, that's significantly different than if we do all the students in this room, right? My age would definitely bump that mean age up significantly, especially right now with the smaller group, okay? So some skewness and outliers affect the mean, and since the standard deviation is the average distance from the mean, okay, the standard deviation is not good if the mean is not good, and the mean is not good if there's strong skewness or outliers. Is everybody good? Okay, and likewise, if I'm describing asymmetric, I might use the median and the IQR to describe spread. The reason I would want to say use that IQR instead of the range, right? Because the IQR and the range I can get from the 5 number summary, but the range is going to include outliers, right? Because max minus min, if outliers are present, either your max or your min is an outlier. Is everybody good? Yeah.
This is not directly related to this, but when we're talking about Q1 and Q3, is it like 75% is lower than the Q3 and 75% is higher than Q1? How does that
Sure. I mean, I think it's worth noting that essentially means Q1 is your 25th percentile.
And then 50% of the values are between Q1 and Q3? Or is that
Yep.
always true?
That is also always true. But the median is not always your midpoint between Q1 and Q3,
Okay.
right? But, so yeah. So like I could interpret this as 25% below or 75% above.
Yeah.
To me, those are the same thing. Okay? Everybody good? Now, all of these are what I would call measures of position. They kind of describe where certain values lie. Okay? Outliers. We had 2 rules. We had the IQR rule. So the IQR rule is anything that is more than 1.5 IQRs from either Q1 or Q3. Technically, strictly equal to is not considered an outlier. It has to be strictly more than. Okay? The other rule we have is if we have a nice symmetric distribution, something's an outlier if it is more than 2 standard deviations from the mean. Yep.
How do you calculate the IQR again?
Q3 minus Q1.
Okay.
Everybody good? Okay. If a distribution is symmetric, the mean is approximately equal to the median. They're not necessarily perfect, okay? If it is skewed right, that would mean the mean is bigger than the median. Skewed left, the mean is less than the median. And sometimes if you're like, I can't really tell, this is kind of symmetric, it's kind of skewed, one of the things you might do is look at the mean and the median and let them help you make that decision of whether or not, and frankly, the bigger the skewness, the further the distance those things are from each other, okay? All right. what is a graph of the 5-number summary? Do I have that? When we draw a box plot, it is a graph of the 5-number summary. It can also help me see skewness, right? Like if I see a bigger distance between my median and my Q3 than between Q1 and the median, that would suggest to me also skewed, right? Okay, like you can, like these relative distances or these relative distances can help me start to see some skewness as well. Okay, we're looking for imbalance. Where is it more stretched out or not? The skewness is where the stretch is. Okay? All right, number 1. So one of the things that showed up for a decent chunk of you, if I give you one group and I ask you to say what's going on between the group and just summarize, you describe the shape, the center, and the spread. If I'm asking you to compare 2 distributions, what I need you to get that didn't necessarily showed up, if I'm asking you to compare, which on that practice test you guys had to compare 2 right-leaning, 2 right-skewed histograms, okay? The word than needs to be in your answer. So it's not enough to say this group had a mean here and this group had a mean here. Instead, what you wanted to do is say this group had a higher mean than this one. This group was more spread out than this one. So if you don't have the word than in your comparisons, we got a problem. Thanks, guys. Have the next page? Sure don't. Now, transformations is something that really jumped out on the survey that I sent you guys of, like, you wanted a review of transformations. When we talk about transformations, this is like if I add the same number to every value in a data set, what would happen to the mean, what would happen to the standard deviation, okay? So let's say I start with the data set 5, 6, 6, 6, 8, and 9, okay? And if I average those right now, you guys don't need to. I'm going to say my X bar is 6.67, yeah? And I'm going to use my range as my measure of spread, which would be 9 minus 5, which is equal to 4. Is everybody good? All right, now imagine I create a new data set by taking every single one of those values and adding 3 to it. So if I add 3, the 5 becomes an 8, all the 6s become 9s, all the 8 becomes an 11, and the 9 becomes a 12. Is everybody good? As I'm looking at that, does anybody want to guess what the mean of that would be? Yeah, it's going to be 9.67. It's going to be 3 units higher, yeah? So when I add and subtract, the mean changes with that. Now, what about my range? In this case, like, essentially, if you imagine this dot plot versus this dot plot, all I would do is just shift this one over right 3 units. So the mean would go with it, but the standard deviation, it's not going to be more spread out. Okay? So the range would still be 12 minus 8, which is 4. Okay? So the mean changes, the range stays the same. Okay? And what we need to see with that, the mean is a measure of position or a measure of center. So the mean, the median, Q1, Q3, all of those things are all measures of position. All of those would change. The range is a measure of spread. Measures of spread stay the same. All right? Now, let's instead say I took this exact same group and I multiplied it. Yeah.
Wait, so what would happen to the standard deviation then?
Since it's a measure of spread, it would also stay the same. Okay? Now, if I multiplied every single one of those values by 3, I would get 15, 18, 18, 18, 24, and 27. And I just typed those in, y'all, and found my mean. And guess what? I got my mean to equal exactly 20, which happens to be 6.67 times 3. What about my range? What's my range here? 12. So what happened to my range? It also got multiplied. So when I multiply, those values the distance between those values gets bigger. Is everybody good? So when what I'm doing in multiplying and dividing, my measures of position / center, well, those change. And my values of measures of spread also change. And the way you're most likely to be asked about these is, let's say we have the variable x is the number of coffees sold from 7 o'clock to 8 o'clock on a Tuesday has a mean. This is at like a coffee shop or something. Okay, I made this up on the fly really quick when you guys asked for this. Has a mean of 6.34 and a standard deviation of $1.45. So this is number of beverages sold. Okay, imagine we walk into the Stops or the Grandview Grind. My guess is it's probably a significantly higher number than this, between 7 and 8. But you know, I was working real quick. Okay. All right. So now it turns out that the profit in terms of materials for a singular cup of coffee is $2.78. But on top of another, so this would include, say, the cost of supplies, but then you also have to pay for rent and the employees, etc. Okay, so that's the intention of this equation. Okay, so if I sold 8 cups of coffee, my profit would be 2.78 times 8 minus 1.65 or 1.25. Like that's the intention. Okay, so this would be us doing a transformation based on the number of cups of coffee that were sold. Right? And so now I have 2 operations. The first thing I'm going to do is 2.78 times x. If I multiply by 2.78, what's going to happen to my mean? It will also get multiplied by 2.78. What about my standard deviation? If I multiply by 2.78, will the standard deviation change? Using the wrong number. All right, after I multiply by that 2.78, I'm going to subtract $1.25. If I subtract $1.25, will my mean change? Yes. Will my standard deviation change? No. So my mean of y my standard deviation of y all right. Does anybody know what time the bell rings? Great. All right, percentiles. If something is, say, the 63rd percentile, that means 63% of observations are beneath that. So let's say 65, for some distribution, 72 is the 63rd percentile. That would translate to 63% of observations are less than 72. Okay? Z-scores we calculated by doing the value minus the mean over the standard deviation. And it is the number of standard deviations above or below the mean. For every percentile, there is a z-score. For every z-score, there is a percentile. Specifically related in the normal distribution, right? So if we know something's the 35th percentile, we can figure out how many standard deviations it is below the mean using, say, inverse norm and all those kinds of things. Not many people mentioned wanting a review of the normal distribution. I'm going to do real quick. Like the empirical rule is 68, 95, 99.7. Those are the percentages in between 1, 2, and 3 standard deviations from the mean. If you describe something as normal describes shape, and then you complete a normal distribution by saying approximately normal. That only describes that it's bell-shaped, then you're going to add the center and the spread. So add the mean and the standard deviation. Okay? Normal CDF finds areas. Inverse norm finds boundaries. In terms of what are you given? If you're drawing a picture, or when you're using the normal distribution, it is bad to say normal CDF 5, 8, 7.2, 1.5. If you only gave me this, you would not get full credit. If you labeled this as the mean and the standard deviation, you might get full credit. Okay? But if you only give the calculator speak, you will not get full credit. Drawing the picture automatically gets you that credit, which is why this entire school year I have required that you draw the picture, because it communicates everything we need to know. I got one more thing from the previous page that I forgot that I think goes important with level